It's finally time to tackle our rollerball project. You might say that we haven't done anything substantial yet, but this is wrong. We made a plan, and a plan is important. So let's take a look at what our plan wants us to do. Here we have our 5 steps, and the first thing we should tackle is the world or the level. This sounds like a great idea, and it sounds like something for which we can use a task branch. So a good place to start would be to create our first task branch. Let's switch to plastic. We can see that the latest change set is the one we created in the last video because the comment says Start Setup. This is the right place to branch off from. We choose Create Branch from this change set and use a reasonable naming pattern for a task branch. Prefix it with branch and then a reasonable, very short title like Create Level. Beautiful. The branch is created and the tiny house icon shows us that our workspace automatically switched to the new branch. Back in Unity, it is a bit more tricky to see on what branch you currently are. But since we switched to a branch and not to a change set, you can immediately tell on what branch you are down here in this somewhat weird looking repository location string. Awesome. We know that we are on the correct branch, so let's actually get our hands dirty. In my case, I want to move into the directory for my actual project and in here create a scene. It will be our only scene, so we don't need to be too creative when it comes to the naming. Then just switch to the new scene. Our current task is to create the level. So I simulate that by adding a couple of objects to the scene. With the current camera setup, we don't really see what we added, and we will fix that in a second. But in the hierarchy, we can see a ground object, which is just a plane, and a couple of walls objects, which are simple cubes scaled in such a way that they form walls, such that the ball cannot escape. This seems like a nice first draft for our level. And obviously in a more serious game, there would be much more work to do. But probably most of that work would also involve adding and manipulating stuff in the scene. So we want to be good version control Padawans and check in small logical pieces. So this is a good moment for the first check-in on this branch. Before we check in, just note that there is no div which we could inspect yet. Because the scene is just being added, so there is nothing to compare it to. This will change in a second. Perfect. Now we realize the way the camera is set up is not of much use. So let's remove the old camera and light and paste in the correct one. Now the player can actually see something. This time, before we check in, we can have a look at what the div of the scene looks like. And here you have a perfect example of why during the course I gave you a warning on working on scenes with several collaborators or as a team. All we did was change some settings for light and camera, but the textual representation of those changes is a mess. Technically, of course, all of that is correct, but if you had to resolve a conflict on the basis of this div, you might have to spend rather hours than minutes. We will talk about conflicts in much more detail later in the course, but here you can see a nice example why working concurrently on a scene might lead to a lot of additional work. Now, this is not always the case. Sometimes changes in a scene are very readable and understandable, but in general, we should look for other solutions. In this first project, however, there is just one dev and no collaboration, so we don't really need to worry about it and can just check in the camera changes. In the next step, we will add the player game object to the level. Since we are at the task level creation, at this point we are not concerned with any player functionality. All we want to do is decide his visual appearance in the level, which in our case is as simple as adding a correctly scaled and positioned sphere. Let's again have a quick look at the div of the scene asset, where the changes are much more understandable this time. Because we have this nice, concise block, if you look closely, you can see that those changes are very similar to what you would see in the inspector. Because this time we have this nice, concise block, and if you look closely, you can see that those changes are very similar to what you would see in the inspector. We can see we added a new game object, and all of its components like a rigid body, a mesh renderer, or a sphere collider. However, again, just adding a simple sphere produces a lot of additional text for the div. So if there would be more work to do on the player object, I would definitely turn it into a prefab. And you will see in a second how this can help with version control. In our simple example here, the player game object is finished, so we can just check it. We are almost done with the level creation task, but there is one more thing I would like to show you. And for that, I will pretend that I really don't like the fact that everything is just white here and we don't have a nice contrast on the player, for example. So I want to change the color of the ground object. For that, I will create a new material asset and set it to something nice and dark. Then I add the material to the game object, nothing special here. However, I would like to draw your attention to our pending changes window. As we would expect, we can see the added material and some change in the scene file. When we inspect the div, however, at this time you can see that only one line is affected by our change, and everything else remained the same in the scene. All that happened in the scene file was that a new material is referenced, and the actual details on the material, like the color we chose, is stored on the material object and is not polluting the scene file. So this is the kind of change that is good if you need to work concurrently, because everyone now will be able to understand the change rather easily. In this first task, we saw how different changes to the scene affect its textual representation, which might affect how hard our work on the version control side of things might be. For now, we are happy with our level and thereby finished the task. This means that it's time to merge the changes to the main branch. We switch to plastic and we can now see the progress we made on the task and our little change sets. We did a good job of separating the work into nice logical units. So whenever some coworker would review or check out one of our change sets, he would get a clean and understandable state of the project, which is very good. We want to make the changes available to the main branch, so from the last change set, we can choose merge from this change set to, and the only logical option for the destination is obviously the main branch. We then get a nice summary on how the merge will affect the main branch. We did almost all of the work in the scene file, and the only other file we added was the material. So this all looks pretty correct to me, and I can check in the merge. The result is a new change set on the main branch, which has all of our new changes. We want to continue our work on the next task from the main branch, so the last thing to do is to switch the workspace to it. That's it for the first task. I hope this was useful, but we are far from being finished with our game, so let's not waste any time and have a look at the next task in the next video.